We're going to start a new unit today on significant figures. We're starting to get into the math portion of our chemistry class.
All right, so significant figures. Let's see, what are significant figures? Sig figs, we sometimes call them. Hey, there's a little extra.
Very commonly, because it's easy to say
point
sig
down there.
figs.
So sig figs are digits of a number that carry meaning that contribute to the precision of the number. And when we talk about precision, a lot of times we're talking about measurements. So sig figs generally arise from measurements, only measurements as a matter of fact. Counts and definitions have an infinite number of significant figures, so we really don't talk about how many sig figs, and we'll kind of get into what is it, well, maybe we should just call it, I don't know. Okay. So counts and definitions have an infinite number of significant figures. What does that mean? A count is like saying there's 25 people in the room.
2, 3, like an exact number.
Yes.
Anything that's exact.
And then a definition.
We don't worry about this thing called sig figs, which we'll define here in a minute.
And then the definition means that it's like 3 feet in a yard. There are 3 feet in a yard. There's not 3.0 feet or 3.1 feet in a yard. There's 3 feet in a yard.
Yep, that's a definition. It's like a conversion from one thing to another.
Which we'll get into later in
We'll
this
get into
unit.
conversions.
Yes.
So let me just share a joke with you, if I may, on why this is an important concept. Recently I went overseas and I got to visit the pyramids. Somebody told me the pyramids were about 6,000 years old. Right?
Really?
Yeah.
Okay.
And I went to see them 5 years ago. So the pyramids must be how old?
Well, 6,005 years, right?
6,005 years. But that's not actually the case.
Are you sure?
Because this number, it's not exact. This is an estimation. They're approximately 600. So I can't add an exact number to an approximate number and get an exact number.
Oh.
It doesn't work. It's just an approximation. So this is really
I thought you were onto something there.
No, it's 6,000. It's like they might be 6,000 years old. They might be 7,000. They might be, or like 6,500, 5,500. We don't really know. It's a guess, about 6,000. So we can't add 5 to that and say there's 6,005 exactly. It's just an analogy to show why we have to worry about, really it affects when we're doing labs, how we measure and round numbers in a lab, because some of our numbers are estimations like this, and we add and subtract with estimations differently than we do in your calculator, because this is clearly not what you get in your calculator, but logically it makes sense, because you have an estimation and an exact number. This exact number doesn't really matter because it's not big enough. So the first thing we need to do is distinguish between, we're trying to identify if something is a measurement or a non-measurement, and that's going to tell us if the numbers are significant, because we really want to see, when you think about significant, it's like, do the numbers matter? Do we need to worry about rounding them?
So a couple of just quick definitions here, or I should say examples, not really definitions, because these go along with the definitions we just talked about. But my desk is 4.75 feet long. That is for certain a measurement.
That is a measurement, okay? Now that's important because measurements matter. Measurements have significant figures. We need to worry about these numbers, which we'll deal with in a little bit.
So there are 27 people in our class. I think it's pretty similar to the example I said on the last slide. That's a count. There's not going to be 27.1 people, hopefully at least not.
Exact.
There's like a finger laying on the floor.
Something that's exact. One finger laying on the floor?
Well, that's like the 27.1, right?
Just slide that in there.
That's not going to happen, though.
That's an exact number. Exact numbers, they're not rounded at all. So we don't have to worry about significant figures. All the numbers are important. 27 exactly. This number here, since it's a measurement, it's rounded. If you think about using your ruler, you kind of round this last little place here, which makes it, we have to deal with that a little differently than this one. If you count, there's no rounding there, it's exact.
Then the last one, there's 100 centimeter and 1 meter. That is a definition.
Definition, that is also exact. So this number, we're not going to worry about as much because there's no rounding involved. It's exact. We're not going to worry about which numbers are significant because all of them are.
Okay, so we need to talk about how do we know how many significant figures there are in a number.
And these are, remember, these are the ones that are measurements. We're trying to figure out, since it's a measurement, which numbers matter and which ones don't. That's what we mean by significant.
So our rule that we're going to use, if there is not a decimal point, is not. That's really important. So
Whole numbers.
we really have to, the first thing you have to do when you look at a number is judge, does it have a decimal point? Does it not? Easy thing to do. So the rule is that from right to left, you begin counting the digits, starting with the first non-zero until you reach the beginning of the number. So we're counting backwards, basically, from the end of the number to the beginning, starting at the first non-zero.
And really, the only thing we're trying to worry about when we're counting is zeros. Because sometimes zeros are placeholders, and placeholders don't really matter. So we're trying to identify the placeholders.
No, they matter because they hold the place.
Well, they hold the place, but
they're not significant.
They're not significant.
Yeah.
They're insignificant.
Right.
They're just taking up place.
Basically, remember when we say the word significant, we're talking about contributing to the precision of the number, not whether they need to be in the number or not. Because they clearly need to be in the number, because see that bottom one?
They hold the place.
18,030 is a lot different than 1,803.
They're different numbers. So they're important placeholders, but they don't matter. So let's look here. Right to left, counting digits starting with the first non-zero. So there's no zeros in here. Both of these are significant. We're just trying to figure out how many numbers in that, how many digits are significant. Both of those are significant.
So we would say we have two sig figs, or two significant digits.
Two sig figs. All right, second one.
Starting at the first non-zero.
This is a zero. This is a zero.
There's our first non-zero.
There's a non-zero.
In fact, it's the only...
100 only has one sig fig.
That was a poor measurement, basically. If you have one sig fig like that, you didn't take a very good measurement.
It's like 100 plus or minus 100. Yeah. This zero and this zero are placeholders. They don't really matter as far as the measurement goes. It's just one sig fig there. 18030, start at the end. This zero is a placeholder. And then everything after it is significant. So this one has 4.
Right, so that other zero that's in there between the 8 and the 3, that is a significant digit. The one on the end, however, is not. It's just the placeholder.
So whole numbers, the zeros on the end, are placeholders and not significant. The opposite is true if it's a decimal. So now we've got a whole number rule and we've got a decimal rule. We're going to start from left to right, and we're going to try and find the placeholders at the beginning. And we're going to skip them.
Okay, so the rule, just to read it out, from left to right, begin counting digits starting with the first non-zero until you reach the end of the number.
The end of the number.
So, yeah, this is like normal counting left to right.
So no zeros here, 3 digits. They are all significant. 6.53. That has 3 significant digits in the measurement.
Okay.
24.30700. Okay, well now we're starting at the left. There's no placeholders out in front. So we started at the 2. Everything after the 2 is significant.
Okay, so now those zeros at the end,
even these,
unlike that last slide, they are significant as well, or else we would not have added them.
Those 2 on the end are significant. They do matter.
So there's 1, 2, 3, 4, 5, 6, 7 sig figs.
Because it's a decimal. We're only looking for numbers on the front that are zeros. Like in this example, 0, placeholder out front, placeholder out front, placeholder out front.
There's our first non-zero, that 8.
4 are significant. We still have to write the placeholders, but because they give it a definition, but they're not significant measurements.
So they don't contribute to the precision of that measurement.
Scientific notation is really nice because if you have numbers in scientific notation, they are all significant. If we have 300, it's 3 times 10 to the second. There's 1 sig fig there.
The times 10 to the second, not part of your significant figure.
Just the 3. Because what does scientific notation do? It gets rid of the placeholders if you do it correctly.
Mm-hmm.
So 1 significant figure. 3250, that is a whole number, so I'm going to start from the right. Those are significant. That's a placeholder. 3.25 times 10 to the third. 0.0002560. Well, starting from the left, placeholders, get rid of them. And we've got 2.560, the last one matters, times 10 to the negative fourth.
Yep, so we're going to use these for numbers that are either really big or really small, which we actually get to deal with a lot of in chemistry. So it's important you kind of have a general grasp of scientific notation and how to do the sig figs in scientific notation. So if you don't remember what the times 10 to the second means or times 10 to the negative fourth means, that's something you should go ask your teacher to get a little refresher on.
And we are going to use this all year. We're going to do a lot of math after the rest of this chapter, and you're going to get points on every problem you do for counting and rounding sig figs. This is just not going away.
All year sig
This
figs.
you might say this is a significant lesson.